All right, section 5.1 is on extreme values of functions. So whenever you see extreme values, you're just thinking of maximums and minimums, so the highest and lowest points. Okay, so function f has an absolute maximum, or sometimes it's called a global maximum, at c if f of c is greater than or equal to f of x for all x in the domain. Kind of confusing. Basically, it's saying the y value is higher than any other y value in the domain. So there'd be a maximum right there. This would be an absolute, well, not necessarily an absolute minimum. So let's say it goes something like that, and it tapers off, and it stops there. Okay, so this would be an absolute max, this would be an absolute min. Basically, they're the highest points and the lowest points. Okay, we call the maximum and minimum values of f extreme values, or extrema. Okay, so function f has a local maximum or relative maximum, so we call it a local one if it's just the smallest in that general area. So like looking at example 1, this point right here, that would be a local minimum, because in that general area it's the smallest point, or the lowest point, did you guys see? But for the whole thing, it's not the global minimum. It's not the lowest of the whole graph. Okay, so that's going to be important too. So local versus absolute. Okay, so number 1, it says find the local maxima and minima and absolute maximum and minimum in the following function. I don't know why I said maximum, minimum. I guess there's one. Oh yeah, there's one. All right, so local maxima. So where would the local ones be? There's actually 2. We count the absolute one as a minimum as well, as a local one too. All right, so the way we write it is we're talking about how high or low something goes. So when we talk about the local maxima or local minima, we're talking about the y value, right? How high or low something goes. Okay, so the way I would write this is I would say, for the minima, we'll go down here, we'll say -3 at x equals 4. And we're going to say -7 at x equals -10. So you talk about the y value. Yeah, I was asking maxima before, wasn't I? That's why you guys said there was one. All right, so the local maxima is where? Yeah, and we're going to say 9 at x equals -5. Okay, since that's the only one that's also the absolute, or is it? There's none, right? We would just write none. Do you guys see why that's none? Because this goes higher than that point. Okay, and there's no highest point. All right, how about the minimum? Absolute minimum? Yeah, so it'd be -7 at x equals -10. So that's the lowest that it goes. All right, number 2, find the maximums and minimums, or maxima and minima, local and absolute of f of x equals sine of x. Okay, this is a hard one. So think about what the sine function looks like. Two pi is where it completes the period, so where it starts over again. So that means pi is directly between. So what would the local maxima be? It's 1. Where is it? Yep, it's at pi over 2. This would be 5 pi over 2. Add 4, 9 pi over 2. Okay, and then this is, what's that one? -3 pi over 2. Okay, so we're going to say at x equals pi over 2 plus 2 pi k, where k is an integer. Right, you either add 2 pi or subtract 2 pi. So it's 1 at x equals pi over 2 plus 2 pi k. Okay, how about the local minima? It's negative 1, right? That's the lowest it goes, a negative 1 for the y value. And we say at x equals, you can say it a couple different ways. I would use the positive one. Yeah, so I'd say at 3 pi over 2 plus 2 pi k. Okay, what about the absolute? Yeah, it's exactly the same. It's the same. All right, number 3. So find the maximum and minimums of f of x equals x squared and g of x equals x cubed. Here's what our two graphs look like. So for x squared, do we have a maximum? Right, no max. And then we have a local / absolute min of 0 at x equals 0. Okay, how about x cubed? Yep, no max or min. Okay, so 4, use a graphing calculator to find all extreme values of f of x equals 3x to the 4th minus 16x cubed plus 18x squared. So go ahead and graph that one. And we're on the interval -1 to 4. Did you guys have it? Okay. So mine looks something like comes down, hits, goes up, then it's kind of, mine's cut off, but you can change your window. So it's like that, and then -4 is just to the right of it. Or not -4, 4. And -1 is like right around there. Is that what yours looks like? Okay, so we need to find all extreme values on that interval. Oops, a little wobbly. Okay, so we can use second trace, the second calculate, and we're going to find the maximum. So hit 4. When it says left bound, you want to go left of what you're going to try to find, so get kind of close. I'd get like right around here and hit enter. Right bound, get on the right of what you're trying to find, so get on that side. Guess, get right where you think it is, enter. Mine says 0.9999998.5, so I'm guessing it's going to be 1, 5. If you zoom in a little bit more, sometimes that takes care of the problem. So 1, 5. Remember the calculator has rounding errors. Okay, let's find the minimums. I think I can guess what this one is. Is there any justification on why it's 0, 0? I know 0, 0 is a point on the graph, right? So if you plug in 0 for x, you get 0 for y. So let's go ahead and find it. So left, get on the left, right, get on the right, guess. Okay, again, mine had some kind of rounding error because it says -5.1 times 10 to the -7th, which is 0.00000. Yours may not say exactly the same thing. And then my y value was 4.7 times 10 to the -12, so 0.11 zeros, 4. So obviously it's 0, 0. All right, and then let's try the other one. I have to change my window because I want to make sure I can see the bottom of it. Negative 30, go down there. Yeah, it does go really low, doesn't it? Yeah, I got 3 comma negative 27. Okay. Okay, now it's only on that interval. So that means our graph has been cut off on the ends. So should I also consider those endpoints, you think? Yeah, you should actually consider the endpoints. So we need to find what those are. So what's the easiest way to find what those endpoints are? Yeah, just plug them in. So you can go to table. You could do second trace value. Have you guys used value before? So you can put in negative 1. It gives you a value of 37, which looks just like my graph, let me tell you. So it goes up a little bit higher then. All right, and then plug in 4. So second trace value and 4. So I get 32. Okay, so when we talk about the absolute max, what's my absolute max? 37. So 37 at x equals 1. What's the absolute min? Negative 27 at x equals 3. And then we also need to consider the local max. So our local max, we would also have 37 at x equals 1. Yeah, x equals negative 1. Thank you, Allie. We would have 5 at x equals 1. And we'd have 32 at x equals 4. Local min. So we have 2 local min. So we have 0 at x equals 0. And we have negative 27 at x equals 3. Okay, see how that works? Yes?
So for local max and local min, you just kind of list all the absolute minimums on the
Yep, any like hill or valley, or in this case, see how there was nothing on the other side. So that's the highest point in that general area. Yeah. Okay. Okay, so if f is continuous on a closed interval a to b, then f attains an absolute maximum value f of c and an absolute minimum value f of d at some numbers on a and b. So if it's closed, there has to be some kind of maximum or minimum, right? All right, so 1. So find the maximum and minimum values of the following functions. So let's write absolute. So let's find the absolute maximum and minimum values. So what does it look like the absolute max is? Our absolute max would be right there. So it's going to be f of b at x equals b. So for some function, it's plugging the b value in for x. What about the absolute min? Yeah, it looks like they're even. So we're going to say f of a at x equals a and f of c at x equals c. Those would be the absolute min. See how it works? So 2, I'd say the absolute max, f of b. Do I have to write at x equals b? You guys all get that right. Abs min, f of a. 3, absolute max. Looks like f of b. Absolute min, f of c. so you're always talking about the y value.
Would f of d be the local max?
F of d would be a local. But so would you guys see that, like on this one, this would be a local min and absolute min. This would be a local min. This would be a local and absolute max. So you have to check the endpoints as well.
So on 3, the endpoints would be minimum.
Yeah, on 3 they'd be minimums, right? Okay, number 4.
So basically, every minimum is going to be a local minimum.
I don't know. Let's look at this one.
Okay.
Okay, so I would have a absolute and local at 10, right? So absolute max 10 at x equals 3. I'd have an absolute min of -1 at x equals 6. But what about the locals? Would I have another local max? Nope.
Yeah, because it's not filled in.
Right, because it's not filled in. So then it's like, well, is it 2.9999999, 6 point whatever? Is it? No. We would say that there is no local. So this is no local max. Because it's an open circle. So that's what Allie was asking. Are all of like the hills and the valleys, are those always local? It has to be filled in order for it to be local. Yeah.
Would 4 at -2 be?
Yeah, this would be a local min.
But it wouldn't be an absolute.
Right, it wouldn't be an absolute because this one already was. Yep, because the other one was lower. What?
They're not.
Yep. The absolute is always the lowest of all of them. All right, so 5. Okay, so do I have a local min? Yeah, local min of 2 at x equals -1. Local max, or sorry, I mean absolute. So it's absolute and local. Is there an absolute local max? None. So there's no maximum. It goes on forever. All right. So Fermat's theorem, it says if f has a local maximum or minimum at c, and f prime of c exists, then f prime of c equals 0. Okay, so we've talked about that before, how at the hills and valleys, the derivative is equal to 0. The slope is 0 at those points. So be careful. Sometimes people try to apply the converse. So they try to say if f prime of c is equal to 0, then there's a max or min there. But think about x cubed. So at x cubed, right there, at 0, 0, I'll draw in the axis, your slope is 0 there. So your slope is equal to 0 there at 0, 0. But does that mean there's a max or min there? No, it just tapered off and we had a slope of 0 there. So the converse does not apply. Like you can't say if the derivative is equal to 0, then there's a max or min. Because you could have those little, we call these critical points, but. Okay, so a critical number is a number c in the domain of f such that f prime of c equals 0 or f prime of c does not exist. Let's find the critical numbers of the following functions. Okay, so I take the first derivative. So I get 3x squared plus 2x minus 1. Try to factor. Does it factor? Yeah, it factors. I'm trying to find when it's equal to 0. So I'd have 3x minus 1 equals 0 or x plus 1 equals 0. So my critical numbers would be 1/3 and -1. Okay, so something is happening at those points. So there's either like a max or min, or something like x cubed where it tapers off and has a slope of 0, or there could be even vertical asymptotes. This one obviously won't have a vertical asymptote. Do you guys see why it wouldn't have one? There's no denominator, right? Okay, so this next one. You could also have cusps and corners too. Cusps, remember that? Corners. Okay, so f of x equals x to the 2/3 times 2 minus x. I'm going to multiply n first, so I'm going to have 2x to the 2/3 minus x to the what power? 5/3, right? Okay, so f prime of x equals 2 times 2/3 x to the, subtract 1 from the power, so it's negative 1/3, minus 5/3 x to the, subtract 1 from the power, so it's 2/3. So I get 4 over 3 x to the positive 1/3 on the bottom, minus 5 over 3 x to the 2/3. Okay, this is a hard one. Okay, you're trying to find when it's equal to 0 or when it's undefined. Can you guys tell where it's undefined? 0, because you're taking the cube root down here. This is the cube root. So that's undefined when x equals 0. Okay, so let's find when it's equal to 0. Okay, so I would need to get common denominators, or you could add the 5/3 x to the 2/3 to the other side. Let's go ahead and get common denominators though, because if you have 3 terms, you wouldn't be able to do that. Okay, so how do I get common denominators? So I want this second term to have what denominator? 3x to the 1/3. We already have 3, so I need to multiply by x to the 1/3 on the top and bottom. So I get 0 equals 4 over, I'm going to have 3x to the 1/3 for both of them. And I'm going to have minus 5x to the, what power? I heard someone say it. It's just x to the 1, right? Because 2/3 plus 1/3 is 3 over 3, which is 1. Add your powers. Okay, so I have x equals 0 is when it's undefined. So that's a critical point. And then the other one comes from 4 minus 5x equals 0. So that would be at x equals 4 over 5. That's the other critical point, or critical number. Okay, does that make sense? So you find when it's undefined and when the numerator is equal to 0. Okay, so we talked a little bit about when you have a closed interval. So when you have, it's not going off in both directions, when it's just closed, like your graph stops. So it says to find the absolute maximum and minimum values of a continuous function on a closed interval. So that's very important. You find the values of f at the critical numbers. So you kind of find how high and low it went at each hill and valley. 2, you find the values of f on the endpoints. 3, the largest of the values from 1 and 2 is the absolute max. So the largest y value is absolute max. And the smallest is the absolute min. Okay, this is very, very important on the AP test. So this is definitely a flashcard one. I put this on a flashcard. Because they always try to trick you. They always make things closed intervals. And then they ask you to find the absolute max, absolute min. They usually do it in like story problems, like find the maximum profit on this interval. Okay. So the first one, so find the absolute maximum and minimum values of f on the given interval. So the first step is you take the derivative. So I have 6x minus 12. Set it equal to 0. So I get x equals 2. That's the location of a max or min value. It's not necessarily a max or min, or it's not necessarily the absolute max or min. You can answer, it's fine. It's just an interesting ringtone. All right, so plug 2 in. All right, so I want to check things on the left and right. So if I check, let's say 0, if I check it in the first derivative, f prime, if you check 0, do you guys see how you get a negative out? You'd have 0 minus 12, which is a negative number. Okay, that's important, so that's negative. Now let's try something on the right side. Let's try 3. If you try 3 in the first derivative, what do you get? Positive. You get positive 6 out. You plug in 3, you'd get 18 minus 12, so positive. Okay, what this means is that your graph was going down, and then all of a sudden it went up once you got a 2. So is that going to be a maximum or minimum? Min. Okay, but we're not sure if it's the absolute minimum yet because we need to check the endpoints. So I also need to try, well, let's find what f of 2 is. So when I plug in f of 2, I get, into my original, I get 3 times 2 squared minus 12 times 2 plus 5. So 12 minus 24 plus 5, so I get negative 7. That's what f of 2 is. You also need to check endpoints. So I need to find f of 0 and f of 3. Okay, f of 0 is really easy. F of 0 is just 5. F of 3 is not so easy. So 3 times 3 squared. I'm writing, but it doesn't let me, so I'm going to put it in here. So 3 times 3 squared minus 12 times 3 plus 5. You end up with negative 4. I don't know how I have a red light on my thing now. Okay, so you end up with negative 4. So what is the absolute minimum then? Negative 7. So it's negative 7 at x equals 2. But if one of those endpoints had been lower, then that would be your absolute min. Now, it doesn't make sense that this one wouldn't be lower because you have a parabola, right? So it's not going to come like back down and be lower than that. So that's going to be your absolute min. All right, so you do the same thing number 2. All right, so your homework for tomorrow is to do the quick review. Now, quick review